मैं ना अभी बैग लेके आती हूँ. I'll put that.
Yeah. I think
that would be better.
Okay.
Thanks.
I request everyone to be sit so that we can start the session. As we all know that the availability of clean and pure drinking water are some of the basic human requirements. So this session will focus on key challenges for the access of clean water, purification of existing water bodies to achieve sustainable development goal for safe water and sanitation for all. We are thankful for our moderator, Dr. N. Kelai Selvi, Director General CSIR. I request ma'am to kindly felicitate our eminent panelist, Dr. S. K. Chaudhary, Deputy Director General, Natural Resource Management in Indian Council of Agriculture Research Institute. Dr. V. M. Tiwari, Director CSIR, National Geophysical Research Institute, Hyderabad. Professor K. P. Sudhir, Principal Secretary, Government of Kerala. Dr. Piyum Subindra Singh, Senior Principal Scientist, Central Salt and Marine Chemical Research Institute, Gujarat. Dr. Nilamas Alam, Scientist F, Technology Mission Division, DST. We request moderator ma'am to kindly start the session.
Good afternoon, all of you. Again, another very energetic and interesting session on water. First of all, I take this opportunity to extend a very warm welcome to all the panelists who are sitting here, and especially the audience, because without your support, this is not going to be a very interesting session. And friends, we are going to talk about not only the importance of water, how water could be made relevant, especially when the country is now dreaming in a big way, how India should be positioned in the year 2047. And as all of us know, many times, especially in the olden days, we used to say that if somebody is spendthrift, we used to tell them that he is spending money like water. So that time, no, this kind of a thing was used to criticize somebody. Because that time we thought that water will be always surplus. We never thought that a day will come that we will carry water and we will be deeply worried about water. But now, if at all we are able to describe somebody that he is spending money like water, I think it is a great credit and honor, and we are appreciating that. So this is a kind of changing scenario, because water is very elixir, even though water is found to be present everywhere. How best we are going to map it, how best we are going to manage it, and how best we are going to make it extremely useful for its end-to-end applications along with value addition. These are the few points that we are going to discuss in this particular forum, and without taking much of time, I wish to listen to all the esteemed panelists from here. So first one, I just invite Dr. S.K. Chowdhury, Deputy Director General, Natural Resource Management, ICAR. Friends, we have been given 45 minutes time for this particular session. So all the panelists will be restricting their presentations or remarks within 5 minutes so that we'll be able to just take up at least 1 or 2 quick questions. Thank you so much. Yeah.
Thank you, ma'am. Thank you very much. I will not go for any structured PowerPoint presentation to save time so that I can finish within the limit of 5 minutes. My talk, my views will be the transition between previous session, which was on agriculture, to the present session on water. Water being the biggest consumer of whole water resources, roughly 89 or 90% water resources are consumed in irrigation, agricultural irrigation. And within the remaining 11%, the domestic sector and industry sector together they consume this water. So if you go for saving in domestic or potable water sector by 1%, probably you require a lot of investment, a lot of energy, and a lot of dimensions are there. But you save only 1% water in irrigation sector, probably will be equivalent to 10% saving in remaining domestic and industrial sector. Therefore, the agricultural water use need to be very, very efficient, and also you need to have more productivity from less amount of water which is applied. And now what are the interventions? The Indian Council of Agricultural Research, through consistent research efforts of last 6 decades, came up with wonderful irrigation technology, irrigation methods, and also use of saline water, not by desalinization, but by some fill techniques or some agronomic manipulation. You can reduce the salt load in soil and you can save the whole ecology, not only the environment. And this flow of salts, solutes, pollutants, if you monitor correctly and scientifically, probably it will provide much wider and better answers for futuristic questions. And from that point of view, the efficient methods like drip fertigation, drip irrigation, subsurface drip irrigation, these are there now. And these methods have the potential to reduce the water uses by at least 50%. Some of the methods are very highly efficient. And if you reduce water consumption by 50%, you enhance the water productivity by roughly 40 to 45%. So each cubic meter of water used will provide you much better output in terms of monetary gains or in terms of agricultural productivity. Therefore, investment in this line will provide much better solutions, and it will give you rich dividends for futuristic agriculture kind of thing. Desalination of water in agriculture side also, we tried that, but it's very, very expensive. Therefore, the interventions which we have in terms of some aquaponics or the precise use of desalinized water for high value crops, and this is happening mostly in Mediterranean countries, in Egypt, in Morocco, or in Caribbean islands now. And they are producing much more from desalinized water. May not be feasible for Indian context, but certainly this is one of the options which will be looked into in future. Now, collecting water from the environment, harvesting atmospheric water and putting it for agricultural uses, this also appears to be very, very expensive kind of intervention. Therefore, most of the interventions from ICR sites are there on the ground. For example, in surface irrigation, we have devised wonderful irrigation methods which are there for surface irrigation, because half the use is from groundwater and more than roughly half the use from surface water. Now, the potential created and potential utilized is much more in groundwater as compared to the surface water, I mean canal water and reservoir water. In canal water also, this automated systems or automation of canal irrigation systems, it is providing much better avenue, and we are able to save roughly 30% of canal water which is being diverted for agricultural uses. Now, in the farm there are much far better techniques now, like subsurface drip fertigation technology, and the state of Gujarat, state of Maharashtra, Tamil Nadu, Karnataka, these are the far ahead states in India which are using this technology to the greatest extent. The automized irrigation system on ground, particularly the horticulture crops, horticulture fruit crops, they are the better avenues for water saving, for enhancing nutrient efficiency, and also energy saving, and ultimately much less gases emissions are there from this kind of system. So in futuristic kind of interventions, we need to find out some solution where CSIR, DST, ICR can come together and come up with the solution to find out the technology so that we can reduce the specific iron toxicity in water, like arsenic problem in Brahmaputra basin, in Indo-Gangetic basins, or in West Bengal and Assam. This arsenic problem is too much, contamination is very high. Fluoride contamination right here in Gujarat state, and also in some areas of semi-arid region. There also you require some solutions which can provide you better answer. With the least investment, you can provide not only good water for agriculture, but also good water for drinking purpose. The Atal Bhujal Yojana is one of the prominent scheme launched by the government of India, and also the Pradhan Mantri Krishi Sinchai Yojana. These two schemes, they are having much better dimensions and much better scientific interventions into groundwater. Groundwater is a major concern now, and we know that groundwater, if we take holistic view, then probably the groundwater management and groundwater aquifer management and mapping, I'm very happy that our institute at Hyderabad, they came up with the herringbone method of mapping, and this will provide better avenues for coming up with better policies. Whole water sector, if you keep on talking of technological interventions, you will not be able to achieve the solution. But if you do right kind of policy interventions on ground, then by simple policy interventions, you will be able to provide better solutions for future. So I would like to stop here and will be available for any kind of questions if you have. Thank you very much.
Thank you, Dr. Chaudhary. Thank you for the interesting remarks. So when the whole world is going for desalination, I think you made it as a point that India should learn. India-centric thing is we should try to make use of even saline water. I think it's a good takeaway point. Now we have Dr. V.M. Tiwari with us for his remarks. Director, NGRA, a CSIR group of institution. Yeah.
Can I have a slide? Very good afternoon, namaskar, and also a privilege of mine to have this kind of interactions with all the stakeholders of the water. And I thought while sitting in the audience, learning from the agriculture sector discussion, that let me put few of the statistics which could be of interesting to everyone. And what I'm trying to narrate has already been discussed, so I would not go in detail. What I would like to emphasize over here, that when we are talking of 2047 and the statistics what it shows 2050, the requirement for the agriculture will be almost 40% more than the present day requirement of the water. And therefore, the 90% water where we are investing, we are using for the agricultural purposes, which brings almost 16% of the GDP of the country, and most importantly, had the largest sector of employment in our country. Therefore, we are connecting kind of a substance with the people, prosperity, and the planet, where we talk of the security of the water through food security and environmental flow to the sustenance of the ecosystem. Next one, please. There was one study which brought us to understand that the kind of the requirement what we are going to have, and the deficit, particularly the places like Punjab, Haryana, and Uttar Pradesh, is amounting almost 30 to 50 cubic kilometer of water every year. And there is no way that the surface water management can take care of it. And as my previous panelist had mentioned, there is a need of looking for the proper storage which Mother Earth has bestowed to us, and we need to really think of that, and that is nothing but the aquifers lying below our feet. and that can sustain the water requirement for the, our country. Next one, please. Next one, please. Next one. Next one. Next one. With this slide, I just thought we would like to share with you, which might be interest to many of the stakeholders coming from the different parts of the country, an example from Hyderabad region, and how can we meet this demonstration of that in a very humble way. And what does it show? That if we had the subsurface information of our Mother Earth to few hundred of meters, we can know how and where can we store the water. And this has been demonstrated in one of the area, what we call NGRI Experimental Hydrological Park, and that has shown that within few years of managed groundwater recharge, we reached to the kind of the situation that farmer income not only had doubled, but made the change of the reversing of the population coming from city to the villages. Next one, please. Next one. Next, please. So quickly, I would like to say that as we are blessed with the large number of diversity in the country, we are also blessed with diverse geological provinces, which pose a big challenge to understand the subsurface of the Earth. And in that sense, what we find, the 2/3 of the area which comprises of the hard rock covered with rocks which does not allow water to percolate down in a proper way. So I will have 30-second movie. Can you click next? Do you have mic over there? If not, can you switch on mic over there? Do you have mic? If not. So what does this movie show? That the biggest challenge that we are finding here can be taken care of by having the technologies which are available with the CSIR, National Geophysical Research Institute, and can be applied in the different parts of the country in order to understand the subsurface information, particularly the aquifer system in the different geological provinces. Next one, please. And it has a potential to demonstrate, to show that there are several methods which are used in geophysics to map the invisible visible. It's the slogan for the United Nations Water Day. And this shows that we can have a very fast and economic way the survey done through the helicopter. So we are talking of not only the fastness which can be achieved as our target is, but also the economy. Next one, please. Next one, please go ahead. So realizing the fact, there is a now talk of the convergence, and we are very fortunate to have with us the Ministry of Jal Shakti, joining Chairman CGWB. He is also here. We started a mega project, and the place where we are sitting very close to that, we flew, and the entire area of the arid region where we received the less rainfall. The earlier chairperson moderator had mentioned about the monsoon, which supplies the water requirement, and we have the mega project. Next one, please. Just click on. And that makes things very different. In one of the area, this is the kind of the information in the three-dimensional way we can visualize, and we can plan the bore wells from where we can extract the water, and we can also see the places where we can recharge our aquifer system. Next one, please. So this also allows another kind of the issue which we face, the geogenic contamination in the groundwater, and can be managed. One of the example, yes, done. Next one, please. Can be done with the information aquifer maps through the simulations, and say that how much water we can extract everywhere. Next one, please. So this is one example from the places in Bihar, Patna region, where we know the aquifer system. Next one, please. Next one. And with this, I once again thank, and I'm very privileged to have our Honorable DGCSAR chairing this session to support this initiative further forward, to see that we move from left to right, not in the political sense, but in the sense that the United Nations desires for all of us. Thank you very much.
Thank
Jai
you,
Hind.
Dr. Tiwari. Thank you very much for your interesting presentation. I think Dr. Tiwari gave a good message to us, not the last point of him. He just made us to understand that once upon a time we were honestly telling that water is everywhere. Now we started searching where is water, for which he is offering some solution. I think all states can really make use of it. Now thank you, Dr. Tiwari. Now I wish to welcome Dr. KP Sudhir, Principal Secretary, S&T Government of India, for his remarks. Dr. Sudhir, please.
Thank you. I join my colleagues from other states as well in congratulating DST in organizing this event. And it was a wonderful opportunity for all of us to meet together, which was very much needed earlier itself. Since there are no much time given to me, so I'll just come to the point. When we talk about drinking water availability to the common man, we should first think about the water availability as such. Not only the drinking water, but also the water available for any other consumption. You look at the Indians, India's traditional culture, we have 20 major rivers, and the total water availability is estimated to be around 1800 kilometer cube. Now we wonder, why are we talking about the water availability, which is becoming reduced, and then the madam said, water is no more, now we search for water. So annual precipitation is estimated to be 4,000 kilometer cube for us. But if you look at the per capita availability for consumption, in 1990s, it was to the tune of 2,300 meter cube, which came down in 2000 to 1,900 meter cube. In 2025, it is projected to be 1,400 meter cube, and 2050, it is projected to be 1,100 meter cube. We are actually going towards the water scanty situation according to World Bank. And water scanty situation is not a scare situation, it's basically a very alarming situation. I guess all of you have read about the news. Our cricketers were given 3 minutes for showering in Cape Town when they went for a cricket match. And it's in our country, Bangalore and some other cities are considered to be approaching the water scanty situation. But the last week in Bangalore, you know, it is not scanty, it was excess. What does it mean? The climate change is impacting the water sector in a totally different way compared to any other sector. If you look at the average rainfall of India during the last 30 years and the previous 30 years, the average rainfall, if you take on an annual average, it's more or less the same. That means the quantum of water which is coming to the country in the form of precipitation has not changed over a period of time. But the pattern of rainfall has completely changed. If you look at the number of rainy days in the previous 30 years and the current 30 years, it has drastically come down. I don't have a map to show it, but then the number of rainy days in the country has drastically come down. What does it mean? These two statistics you should look at together. One is the average remaining same, the number of rainy days coming down. That means the intensity of rainfall has increased very much, and the frequency of extreme events have increased very much, which is visible these days. And a typical example was yesterday. We had an extensive amount of rainfall yesterday for half an hour, which caused huge flooding in the town, probably because of the poor drainage, but then it was a chaotic situation for all of us. Now the question is, where are we heading to? As I said, the quantum of rainfall which is coming to the country has not been changed much on an annual scale. So the pattern has changed. So now we need to think about conservation of water in a typically different way compared to the previous traditional ways of looking at. One of the possible solutions is efficient water management, as other speakers have already mentioned. Our storage activity has to be totally different. We need to think in a different way how to store this water which is coming in a flash mode and preserve the water for future use. Then the efficiency of water management, whether it is for drinking water or agriculture or industry, has to be considerably changed. And we need to give a lot of emphatic research on the conservation of water as well as the usage of the water. Next point is the groundwater. If you, 10 years back, if you have talked to any villager or a farmer, where do you get water for agriculture? He would certainly say, I just dig a well and the water comes out. And he is never worried about whether there is a continuous storage that can be sustained for future or not. We normally work on a firefighting mode rather than a proactive mode. So the moment we started heating or not getting water from the ground, we thought of, okay, the groundwater is going down. So the over-exploitation of groundwater is taking place. Then we advocated methods for groundwater recharge, increase the water level. Then we also came up with regulations. No, you cannot draw water beyond a limit. All these regulations have come. But then, is that a sustainable solution again? Because you are not getting the same kind of rainfall pattern now. And in a flashy mode, the intensity of heavy rainfall, basically more for a short duration, you will not be able to recharge the water to the extent you are expecting to. That is where I said this has to be linked together. So the conservation of water, the method of recharge, everything has to be done in a separate way. If you look at Japan, they have developed underground storages, pipe storage, tunnel storages. They basically did, like the metro tunnels, they did a tunneling completely and made a complete structure for storing water. Whenever there is a heavy rainfall, they go and store it there and use it for future. That is where we actually need to think about new technologies for storage of water, which can be utilized for the further use. I don't want to extend, the time is very slow, and I just wanted to give an example or a typical case of Kerala. I belong to Kerala, and in the month of April and May, there is always a severity of water shortage in Kerala, and we all wake up, all the institutions come together and advocate for water conservation and other things, and by middle of May, we start getting rainfall. May not be very heavy, but the moment we get rainfall, we forget about the water scarcity, and this needs to be changed. That's why I said, no, we are working on a firefighting mode. This may be the case with most parts of the country, which I am not aware of, but it may be the case with most part of the country as well. So we need to change our way. We need to look for the future. The climate change, IPCC has come up with the assessment report 6. We did a study for the entire country as well as specifically for Kerala. We found that towards the mid-century, there we are going to experience frequent rainfall, that means extreme rainfall, which leads to floods, as well as no rainfall, which leads to drought situation. So all your agricultural activity, industrial activity, and drinking water availability are going to get changed in future as well. So we need to actually invest more on conservation of water, storage of water, and develop technology for making water available for everybody. Just wanted to mention one more point. In 22 years back in 1990, when Bisleri introduced bottled water, I think all of us, including all the people sitting here, were thought this was a luxury. And we were actually feeling that this bottled water is meant only for the foreigners who come as a tourist to the country. But now you can see a water bottle sitting on the table in front of you as well. So the situation has come to a really alarming situation. So we need to invest a lot on providing safe drinking water through proper storage and the filtration as well as the processing. Thank you very much.
Thank you, Dr. Professor Sudeep. He made a few points, like attention-seeking points are intensity of rainfall, quantity and pattern of rainfall, where we don't have any control, whereas we can have better control over management and storage and conservation of water. Thank you very much. Next speaker is Dr. Puyam Subhandro Singh from CSM CRI, Bhavnagar.
Thanks, respected ma'am, DG CSIR, and the respected esteemed panelists. Thank you all present here. I'm coming from, can I see the slide please? I'm coming from CSM Sierra is a CSR laboratory based in Bhavnagar in Gujarat, and I'm going to speak on this membrane desalination technology to produce potable water. I'm coming on behalf of my director. For some reason he was not able to come, so I'm speaking on his behalf. So can I see the next slide please? Water scarcity, as you know, is a measure, it's not just Indian problem, it's a global problem. You know, United Nations General Assembly, Sustainable Development Goal, is this G point number 6 is on ensuring availability and sustainable management of water. If you look in Indian context, as the previous panelists rightly pointed out, is a huge problem in Indian context because the declining is very fast. In 1947, we have kind of 6,000 cubic meter average annual per capita, you know, and it's declined by a factor of 4 by this year. And it's going to be like 1,000 cubic meter by the year when we hit 2030. It's 8 years down the line, and then we will be a kind of very, very water stressed country for a country of such a huge population. What we can do? Desalination is a viable option. We will have very long coastline, you see 7,500 kilometers. So desalination is all about, can I see the next slide? So desalination is a process of removing the dissolved salt from saline water. So you can, it is like you can increase availability of the water by converting seawater or brackish water into drinking water. This can be done very conventionally by thermal evaporation. As you know, you heat the water, you make it vapor, and you again condense it. So it's kind of changing the phase from liquid phase to gas phase, and again from gas phase to liquid phase. So you need heating and cooling, also you need pumping. So equipment size is quite big and hugely expensive procedure. Therefore, it's not that popular. Now we have this advanced process. You have just a series of filter. There is no heating and cooling, no phase change here. You just pass series of filter. We say the first stage clarifier. You remove the suspended and the fine particle. And then you go to the next stage, we say reverse osmosis, where you remove the excess dissolved salt. And you get the mineral balanced water, which is good for health, human consumption. And the reject water goes back to the sea. So this is very nice way of doing desalination, and by doing so, the system running, you just need a pumping, electrical pumping system. Therefore, the energy requirement is an order of magnitude lesser than what thermal desalination is costing. So it's hugely popular, this membrane desalination. If you see worldwide, total worldwide installation desalination plant, more than half, okay, 65% is coming from RO technology only. I just give you a little bit of briefing because it's a good, maybe with interest of the public to know about what is all about this membrane desalination, when it started. Can I see the next slide, please? In fact, this is not very long time ago. This desalination process, reverse osmosis process, started by the breakthrough of this 1960s cellulose acetate membrane. Again, one of the inventors is Indian, Dr. Sauri Rajan, but he was in USA citizen. Laurie Sauri Rajan cellulose acetate membrane. Okay, this is a semi-permeable membrane. It allows the water containing no amount of dissolved salt, and it retains water containing high amount of dissolved salt, and it is done under external pressure in excess of osmotic pressure. So in this way, it is the reverse osmosis process of forcing this drinkable water across the membrane. Can I see the next slide? So again at CSM Sierra, I mean long time ago, during those 1960s, even Dr. Sauri Rajan visited our lab. And we had this research program on desalination to meet the water demand through desalination. We had perfected the technology, and it was transferred to entrepreneurs, and we installed plants those days. And also this has been put up in the bus, and it acts as a mobile desalination. Those days, 1980s. Okay, and two of these plants is gifted to Thailand government. You can see the picture of our Vice President, Mr. K.R. Narayan, giving these documents to the Thailand government officials. Can I see the next slide? But the major breakthrough is this 1980s, we say thin film composite, TFC membrane, because the earlier... Yeah, so this is what we have been working on, and we have also been pioneering in this area. It's a quite delicate and very tricky kind of research. Not many research institutions are working in this domain. Can I see the next slide? Yeah, so I just skip this slide. Again, this, can you please skip? Okay, so this is what, even then we have deployed over the years, we've deployed many plants across India, I mean more than 150 to 200 plants, including a few plants in overseas in Afghanistan and Kenya. We have shown that it's a very robust technology. Even then our presence is very small. It's a big water, big business. What is big business? And you can see now a lot of RO, but you don't see many very few Indian manufacturers because of the policy, because of things like that. But it's not that we are not capable of. Our manufacturers' products are really can be seen in the market. Now, to be able to popularize, we are looking now designing and engineering of mid-size desalination plants. So we are thinking with the help of CSIR and also from DST. In fact, we submitted a proposal to DST, and where ma'am is the mission director, and for the funding, because we also need logistic support as well. So it takes time, but hopefully these are the few challenges we're having. But to be thinking in this line, we need support from the state government as well for because these are arranging the electrification and civil structure and all this. Okay, I just finished. Yeah. Thank you.
Yeah, thank you, Dr. Subindra Singh, for your very interesting information on this one. How best seawater could be, or brackish water could be used as a potable water. I think you made one point very clear, that the Sustainable Development Goal number 6 on a sustainable management of water could be effectively addressed through this particular technique. Thank you. So the last speaker panelist is Dr. Nilima Alam, scientist from Technology Mission Division, DST. Dr. Nilima.
Thank you. Thank you very much, ma'am. I would like to give me this opportunity on behalf of Department of Science and Technology to represent the DST's various efforts in this important area of water. I have 5 minutes. It's a challenge to squeeze in the wide canvas that we have in the area of water and DST's various efforts in past more than 10 years in this area, but nevertheless, I'm going to try my best, ma'am. I think this has been one of the most long drawn and consistent effort of Department of Science and Technology, Water Technology Initiative. We have been working at a very vast and I would say wide canvas, right from trying to develop solutions, technological based solutions for various water challenges, from water quality to water availability, water quantity, recycle, reuse. I mean, when we talk of quality, I mean, I don't have to tell all of you, they can be from arsenic to geogenic contaminants to defluoridation technologies to, I mean, desalination, which is also one of the major focus of this particular session today. We are also working at augmentation of groundwater. There are conservation techniques, there are harvesting techniques, and I think the learned panelist in this particular session has already talked quite a lot about various aspects of working in water challenges. So what I wanted to say was that DST is basically looking at a package of all these different technological solutions. It is a uniquely placed program, I would say, because it is a solution-centric program. We try to develop indigenous and cost-effective solutions, the technology-based solutions in the lab, and then take the lab-proven technologies at the pilot or at the real field conditions. So if I want to come, I would straight away come to desalination, keeping the paucity of time in my mind. But before that, I will say that our arms to work in this particular program is, of course, researchers, academicians, industries, very importantly, also dissemination partners, which is a very important part of this program, NGOs, and very importantly, the state councils, the science and technology state councils. And I'm very happy to see quite a good audience. In the audience, I can see many state councils who have worked with DST in this area of water. If UCOST has worked on a very innovative technology of riverbank filtration, we have Rajasthan State Council, we have worked very, very extensively with DST in the area of desalination. That was the earliest efforts of desalination that has happened in the state of Rajasthan and Andhra Pradesh involving the state councils. Of course, Uttarakhand, Madhya Pradesh, I can see they have worked with us. So that's one thing, and let me come to the desalination part. We all know that keeping the long coastal line of the country in mind and the paucity of potable, safe drinking water also in context, desalination has gained quite a significance in last few years. The government is giving a lot of significance and attention to this major important problem as well as a technological solution. DST is definitely very much involved into it. Of course, our major partners has been CSIR Labs. CSMCRI Bhavnagar has been with us for quite a long time. CSIR Siri Pilani, CSIR NGRI, we have been working in tie-ups and collaborations with all of them with different kind of interventions in the field or at pilot scales. I think Dr. Poyam Singh, the other panelist, has already talked about not just one, couple of actually interventions which CSMCRI Bhavnagar has done in collaboration and support with DST, mobile desalination plant in Latur, drought hit area, to setting up major RO plants in the state of Rajasthan. Also a pressure exchanger based or specialized membrane based RO plants in the Ramanathapuram district, Naripayur. Again, I'll just try to just quickly point out some of the recent desalination efforts done by DST. We have, for the first time, an innovative technology has been deployed and demonstrated in the form of a test bed where industry partner is involved and NIOT or an IIT Madras were involved. The technologies were MED and forward osmosis, and they were both solar powered. And this is a test bed which is already commissioned, established in Naripayur village of Ramanathapuram district, Tamil Nadu, with DST support, and a very good example of enterprise partner, industry partner, knowledge partner, be it NIOT or IIT Madras in the two different projects. And also not only that, the utility partners were very much part of this model where Naripayur Municipal Corporation was part of it. So that was one thing I wanted to point out. Apart from that, we all know we got some directions from the Niti Aayog and also from very high level task force which gave us for certain directions for taking the desalination journey forward. And based on those directions, DST went into a very extensive exercise, and we developed, we first of all launched a call for enrollment of solution providers in 2020, and based on that, yes ma'am, I'm going. So we developed a compendium for status of various desalination technologies in the country. Then based on various stakeholder consultations, levels of consultations, we went into a very thoughtful kind of a call, which for the first time I think DST issued a call in the area of desalination with proper quantitative benchmarks as part of that call. And I'm very happy to say that we got very extensive and quite an overwhelming response, more than 300 proposals. Finally, we could zero down on 20 of them, and we are very soon in the process of funding them. So that is just very recent developments in this area from DST. I've run out of time. There's a lot more to say, but I don't want to take more time than I'm allotted. So thank you very much for your time and attention. Thank you, ma'am.
Thank you, Dr. Nilima. Thank you very much for the interesting points on desalination. And you made us to understand the concerted efforts of industry partner, knowledge partner, utility partner, and technology partner. Thank you one and all. So before we sum up and conclude this session, I wish to take one or two quick questions. Yes, please. Second is yours. Then we'll wind up.
Very good afternoon. I'm from Himachal Pradesh, SS Randhawa. As we all know that Himalayas are under great threat in the present scenario, and we are experiencing a lot of changes as far as water is concerned. My question is to Dr. Tiwari, as we have been using space technology for the assessment of groundwater, is there any technology, what they are using some conventional methods, not possible to undertake surveys like resistivity survey because of the topographical challenges. So is there any, as you shown some airborne surveys, so is it possible to undertake some surveys in the Himalayan region so that we can have some site-specific assessment or a regional scale, sir?
So, thank you. I must tell that the kind of the technology what I have shown for the arid region, which we are going to are working on for the aquifer mapping, same technology we have used for the mapping in the Himalayan region, particularly for the subsurface information, making tunnels right from Uttarakhand. In fact, it's the first in the world in the Himalaya we took the heliborne surveys. But in addition to that, there are other geophysical technologies. We have recently started EVRI, electrical vector resistivity imaging, and that can be done. We can separately discuss. But with permission of chair, I would also like to take 1 more minute to tell about there are several technologies in portfolios of the CSIR which we have not yet discussed and can be of lot of use for the different states. Because you have asked about Himalaya, one of our institute, CSIR ICT, has developed a technology. You can extract the water from the atmosphere. Similarly, we have several, so we are talking of the extracting from atmosphere, we are talking of extracting potable water from the ocean and also from the ground. So all three areas we can cover. The other thing from end to end, if we say from source to the utilization, CSIR offers the different technologies for the contaminant and the other removals, arsenic, fluorides and other. Similarly, they also have the wastewater management technologies, and there is a big compendium of technology compiled and put on the website of the CSIR, and I request all of you who are interested kindly have a look on the CSIR website, which can give you opportunity to know about the CSIR technologies which could be suitable for the different states, particularly to your state. So thank you very much. It was briefly told about DG, but I thought I will.
Yeah. Thank you. Next question, please.
Well, thank you, Chair, and thank you for this wonderful discussion. Well, my friend here has already highlighted the issue. I am from Uttarakhand. I am DG of Uttarakhand State Council. The issue has been flagged, but more than that, one issue which has not been flagged, because we happen to be Himalayas water tower, and we have discussed from, ultimately it has to flow from high to the lower levels. Situation is extremely alarming, and in fact most of our rain-fed rivers, they are virtually on the on the brink of almost they are gone. So it's an alarming situation. Science and technology must come up with some solution. Especially we have these glacier-fed rivers too, the Ganga, Yamuna, and millions of people in terms of food security, this water security, they depend on this. So whether science and technology, we can have some kind of policy connecting these things, especially snow-fed to rain-fed, so that at least not only in terms of giving life to millions of people in terms of this water availability, but at the same time, do we have something of that sort? Water rejuvenation, again, a key point of this panel discussion. I don't know whether how much work has gone into this in terms of science technology initiative. Water education again happens to be something very important. Dr. Niliman, she touched upon this point. And the kind of this immediate need, the alarming situation that we need to address. So do we have something of that sort? So this is what I want to add from our side.
So quickly I would like to answer because we have short of time. For example, the technology which I talked, we have already flew from Haridwar to Chamoli and other areas. So there is a possibility, and fortunately we have with us here today Chairman of Central Groundwater Board. You can discuss realizing the fact of the issues in the Himalayan region, and there are some of the areas which are finding it difficult. Even for example, the place like Jammu and Kashmir, Kathua region, having lot of possibilities. We have a lot of waterfall in groundwater. So how to do it, and Honorable Minister Science and Technology realized this fact, and he had been insisting on us that how jointly with Ministry of Jal Shakti, CSIR can take up such kind of initiative, especially for the Himalayan region, and we are starting from Jammu and Kashmir. Thank you very much.
Dr. Sudhir also wants to make a mention.
Yeah, you were mentioning about the rejuvenation of rivers. I just wanted to give an example of what we have done in Kerala. There was a river which was a perennial river giving water all throughout the year, but then it dried up because of probably rainfall pattern was changed or mismanagement of the water resources. But then there was a watershed management program conducted for 2 years, and the river actually got rejuvenated. And now the agricultural activities in those areas are now intensified. So probably you can also try a proper watershed management program for rejuvenating the rivers. So if there is a dead river, it can be brought up. Thank you.
Nilima.
Just very quickly, I'm going to add one more thing apart from what the panelists have already said. Regarding the Himalayan regions, especially the hilly parts of the country, there is a very, very extensive program going on from DST, from the Climate Change Division of DST, which they are working on glacial technologies. So that is one effort which is already happening from Department of Science and Technology. Apart from that, there is disaster management programs also being evolved in DST, especially for hilly regions, especially keeping the floods and the flash floods in mind. That was another thing I wanted to add. And river rejuvenation is definitely DST's focus, and there has been work done from various divisions of DST, and pond and river rejuvenations has been part of the various field interventions of DST. Sorry, ma'am.
So I think this is a point where we will stop temporarily, and we can continue our discussions during lunch and post-lunch session also. So with this, friends, I'll just take another minute to just conclude this session by saying some 3-4 points. So this particular panel and these esteemed panelists, they make us to understand at least 4 or 5 very important points. As all of us know, necessity or maybe scarcity is the mother of all inventions or innovations also. In that way, this panel, they made us to understand that today's agri sector, it is giving more importance to drip irrigation and surface irrigation, mainly because of that one. Similarly, industries are now given a kind of a great awareness, or I would say it's a kind of an indication that is given to industries to come up with energy efficient and water efficient technologies in one case. And especially the leather industries, whenever they are able to make an announcement that they are able to come up with the carbon free and water free technologies, then they are also coming under acceptable category. So along with carbon free, now it is water free and energy efficiency and water efficiency. These are the added points which are required for any industries to proceed further. This is one takeaway point. And as all of us know, the one panelist made us, I think you made us to understand one point. If at all India is not able to spend that much on desalination, at least we have to come up with technologies wherein we should be able to effectively make use of water with salinity. I think it is another very interesting takeaway point. And all of us know that for any country, water security, food security, healthcare related security, these are all very, very important apart from strategic security. But all these points could be effectively addressed if we concentrate upon water security. Because water is directly and indirectly connected to all these sectors, whether it is energy or food or nutrition or industrial development. Everywhere water is the baseline, and therefore the moment water security is taken care, I think the country is really taking care of all other parameters and dimensions. So, and the last point, all of you, especially Dr. Nilima and the CSMCRI spokesperson, I think both of you made us to understand that technology enabled management of water and storage of water, that is the need of the hour. So with this, for our 5 takeaway points, I wish to conclude this session, and my special thanks are due to all these esteemed panelists for sharing your very, very knowledge-driven thoughts, and I'm extremely thankful to all the audience who were really supportive in really respecting the time as well as to listen to us. Thank you one and all. Thanks again to DST and the organizers.
Thank you so much, ma'am, for moderating and conducting this session. We will now break for lunch. Please note that the lunch break would be for 40 minutes. We will try to regroup at 2 here back for the next session, that's on Plenary Session 7 on energy. The lunch would be at Noble Dome, and we can walk till there or we can use the golf carts available outside. Thank you. We all regroup at 2 o'clock. Thank you. Thank you so much. I'll request our photographers to please take the group picture of our panelists. Okay, we can take. Yeah, he's there.